All right, is that database exam staring you down, feeling that pressure? Well, you're in exactly the right place. In the next few minutes, we're going to slice through all the noise and lock in the absolute must-know concepts you need to crush that test. Think of this as your final, turbocharged review session.
So yeah, the exam is coming up fast, right? Don't even worry about it. We've got this. We're going to walk through the core ideas that are pretty much guaranteed to show up, and we're going to turn that uh-oh feeling into total confidence. You ready? Let's jump in. Here is our game plan for today. First, we'll look at the big picture blueprint of a database. Then we'll check out the tools and the people who actually use them. After that, we'll zoom right into the guts of a database table. And we'll finish up with maybe the most important concept of all, keys. Let's get to it. Okay, kicking things off with Section 1, the database blueprint. You can think of this as the master architecture, the fundamental structure that every single database is built on. Getting this part down is absolutely key to understanding everything else. So, have you ever wondered how someone can, say, upgrade a massive server without breaking every single app that connects to it? Well, the answer is this thing called the 3 schema architecture. Its whole job is to create a separation between what the user sees and where the data is physically stored. It does this by splitting the database into 3 different levels. So at the very top, you've got the external level. This is what you, the user, actually interact with, like seeing your balance on an ATM screen. In the middle is the conceptual or logical level. This is the design, the map of what data is being stored, like the structure of a customer table. And way down at the bottom is the physical level, which is all about how those ones and zeros are literally saved on a disk. This separation is what makes databases so incredibly flexible. This brings us to a classic exam question, so listen up. What's the difference between a schema and an instance? The best way to remember this is that the schema is the skeleton. It's the design of the database, the table names, the column names, and it almost never changes. An instance, on the other hand, is a snapshot. It's the actual data living in the database at a single point in time, and it changes constantly. So what's the big deal with all this separation? Why do we even care? Well, it gives us something incredible called data independence. With logical independence, you can change the middle level, like adding a new column to a table, without having to rewrite the user's app. And with physical independence, you can swap out your old hard drives for super-fast SSDs without touching a single line of code. The big takeaway? Data independence saves a mind-boggling amount of time and money.
Okay, we've got the blueprint. Now let's look at the toolkit. Section 2 is all about the languages we use to talk to the database and the different kinds of people who are doing the talking. You've probably heard of SQL, right? Well, it isn't just one language. It's more like a bundle of 4 mini-languages. You've got DDL, which you use to create the database structure. You've got DML for actually working with the data. Think select and insert. Then there's DCL for security with commands like grant. And finally, TCL manages your changes with commit and rollback. Now, who's actually using all this stuff? Well, you have naive users. And hey, that's most of us when we're booking a ticket or checking our bank account. Then you have the application programmers, the pros who build those apps. You also have specialized users, like data analysts, who write really complex queries. And watching over all of it, you have the DBA. The DBA, or Database Administrator, is basically the boss of the entire database. They handle performance, security, who gets access to what, but their single most important job is backup and recovery. If that system crashes, and I mean really crashes, the DBA is the person who makes sure not a single byte of important data is lost forever. It's a huge deal. Okay, moving on to Section 3. Let's zoom right into the very heart of a relational database, the table itself. Getting the vocabulary right here is super important for your exam, so let's lock it in. For these next few slides, we're going to use this simple student table as our guide. Now, the official term for a table is actually a relation. See how it's got columns for things like roll number and name, and then rows with the data for each student?
So you see that first row of data for John? In proper database terms, that's called a tuple. Yeah, kind of a weird word, I know. But it just means a single, complete record or one row in the table. So John's entire line of info? That's one tuple.
And what about a column? Well, the formal name for a column is an attribute. It represents one specific piece of information about all the records. So in our table, name, age, and course ID are all attributes. Simple as that.
All right, 2 more super quick but really important terms. First up, degree.
This is just the total number of attributes, or columns, in a table. So in our student table, we have roll no, name, age, and course ID. That's 4 columns. The degree is 4. Done.
And the other term is cardinality. This is simply the total number of tuples, or rows. We have a row for John, 1 for Mary, and 1 for David. That's 3 rows, so the cardinality is 3. Easy points on the exam, right? Degree is columns, cardinality is rows. And here we are. Our final and, honestly, probably the most important section, the power of keys. Keys are the secret sauce. They're what let us find one specific piece of data in a sea of millions. And more importantly, they're how we link different tables together. You are absolutely going to see this on your exam. Now, the different types of keys can get confusing, so let's think about it like a funnel. At the very top, you have the super key. That's any group of columns that can uniquely find a row, even if it has extra stuff you don't need. Once you trim off all the extra fat, you're left with a minimal set. That's a candidate key. And then from all your options, you pick just one to be the official identifier, and that's your primary key.
Okay, if you remember nothing else from this session, remember this. The primary key has 2 golden rules. They are non-negotiable. First, every single value in the primary key column has to be unique. No duplicates. Ever. Second, it can never, ever be null or empty. Every row needs a value. Period.
So what happens to those other candidate keys, the ones that were good enough to be the primary key but didn't get chosen? They get a special name, alternate keys. Just think of them as the runners-up. If you have both a unique student ID and a unique email, and you pick the ID as your primary key, the email becomes an alternate key. And now, for the big one, the key that makes a relational database, well, relational, the foreign key. A foreign key is a column in one table that points to the primary key of a completely different table. This is how we build bridges between our data. It's the absolute backbone of the whole system. This slide makes it all click. Look at the depth code column in the teacher table. That's a foreign key. Its only job is to point over to the depth code in the department table, which is a primary key. This creates a powerful connection. It means you can't assign a teacher to a department that doesn't actually exist in your database.
And that is a wrap. We've covered the architectural blueprint, the essential toolkit, the vocabulary of a table, and the incredibly powerful system of keys. If you can master these core ideas, you're not just ready for your exam, you're on your way to mastering the data itself. Now go get them. Best of luck.